Okay. Okay, so we're back online. Oh, hi, Octopus. I just began the stream. So yeah, back for this November session number 29. So it's nearly the end of this November session, and in order to finish this, I think I would want to explore a little bit more the particle man. I know particles body are something that is really explored all over the creative industry, but I saw some of the work made by David MacLeod, and I was thinking about might be interesting to combine some of the particles with some other thing we've made. So especially David MacLeod has a feed which is full of amazing work. So for example, this kind of particle, so you could see it's some kind of, again, a curl noise, and the particle is as a quick a really small lifetime. They fade in and out really quickly. Another experiment from another project you made was this one, and I thought it would be really interesting. So I don't want to reproduce this kind of work, but I'm more in thinking about getting inspired by that in order to make something new with particles. So the main idea for that would be to get to mix the things. So let me show you what I want to mix. I want to mix the body. Where is it? Yes, the ramp we use in order to basically shape the body, okay, with the particle, but I don't want to play with the particle size. So basically what I want to do is first of all spawn a particle on a vertex, but depending on the ramp I will offset this particle based on its on the normal. So basically the final position would be the vertex plus the normal scale to the ramp. And when I've done that, the behavior would be having this particle just having some kind of a curl noise around this place. It might be interesting, so it will not have any physics or anything, and maybe we can have another layer of particle just with curl also, but really small particle. I thought this could be interesting. So the first thing first, I think I will need to recreate a new shape. So we've seen when we try to work with the sphere made from Unity, even if it doesn't has a lot of vertex, when we try to add a lot of particle, it would be a little bit too slow because of the number of vertices, the total amount of vertices which the sphere had. So yeah, I think I would create a new sphere. Okay, so this one. Let's create a new material just to check the texture and to check that the UV are still correct. Oh, I don't want it. Okay. And let's reduce this number of segments. So I want a really low poly sphere, some kind of a some kind of particle like that could be interesting. Let's check. This one is not really interesting. This one could be interesting. The octa is not interesting at all. Or is it maybe an octa might be interesting with that? The icosa. But we've seen that the icosahedron was quite a mess. So let's keep the standard one and let's try to have something like that. 6 is too much, but 8 might be enough. So let's duplicate this just for a moment to check if we break it, the number of how many elements? 26. Okay, and when we try another one, the tetra was not good, but the hexa was quite interesting. Yeah, the hexa was not be interesting at all with that. Okay, so let's work with that one. Okay, a sphere, a standard 8 elements, so that could be our little guy here. Let's reduce it, so let's say 1. Okay, so that's a correct number, and export that. So let's say, where is it? It's here. So yeah, in the geo I will same thing like sphere low poly. Okay, here we are. First of all, let's save our little scene, then we will again duplicate everything we need for that. So this is the 1129. Okay, that's okay for this one. In the model, I will try in the geo to load the sphere low poly. Where is it? It's here. Okay, and the sphere low poly is really big. So let's reduce this one. Scale factor was 501, I think. Would be too big. 0.5. When I'm scaling down the model, I'm trying to reach the maximum size I want if I instantiate the mesh on the scene. So maybe this is not enough. Yeah, something like that, maybe too big again. Okay, let's go for this one. And once again, we will duplicate everything. So I don't want to use the vertex animation texture, so I will try to duplicate shaders from a previous one. So the previous experiment was which one? I think the previous one was, yeah, this one with the light, so it would be good to duplicate this material. And then in the script we need various things. So first of all, I need to duplicate the last compute shader, also the last, not the last, but the previous one, just to be sure that we not duplicate the one with the vertex emission texture we've made earlier today. The controller and the GPU mesh controller, and now we will open everything. Okay, here we are. Let's open all the file we need. GPU mesh controller, the compute shader, and the final shader, which is this one. Okay, so 29, let's rename this 29, and again this would be 29. Okay, seems good. Times to put everything in place. Okay, let's start with 5000 elements. 2, 4, 2. For the mesh, we will use our little simple geo, which is here. Size of 1, 1, 1, 1, 1. 29. Whoops. Whoopsie doopsie. Okay. Even 29. And for the ramp texture, I said that I wanted to explore the ramp 3. And let's remove this component, save everything, check if we haven't, okay, and set the bool for the video export, and that's okay. 1129. Okay. This is really interesting because we see the same behavior we've made with the butterfly, but with only little particles full of glow. So it's kind of interesting. So first of all, first thing first, let's reduce the size, because 0.1 is really too big for me. Something like that might be interesting for the max size, and let's say 21. Okay, so now it's interesting. And now let's go to the surface shader. So of course I need to change various things. First of all, I need to change on this the shader we use. So we use this one, and in the shader I want to get rid of the glow for the moment. So everything we have here, no glow. We only use the RGB color, so that is okay. For the compute shader, although I think for the moment I will get rid of the sequence time, the time and the alpha. We only get the transform and rotation scale for the moment. Did I use? Yeah, I used the in dot color, so I think I might pass a transparent color directly into this. Yeah, that was the mistake. So now this is okay. We have something quite white with a lot of glow, of course, but let's augment the number by saying we want 25,000 elements. So first of all, as you could see, even if I have 25 elements, 25,000 elements, which seems to have the same one, so that's okay. That's the main problem we already had. So let's try to display this. So basically the problem comes from the fact that we have too many particles. We have too many particles on the same vertex. So for example, if my mesh had 100 of vertices and I spawn 1000 elements, it might be logic that a vertex might be might have some more instance than one, because I'm using a modulo, so I might have, if I'm not wrong, yeah, I might have 10 instances on one vertex. So we need to find a new position. Okay, so this is the position, remember. Do we want to keep this or not? Okay, that's okay. So yeah, we need to offset this a little bit, and we already made that in a few various shaders. So I think it might be on which one? Let's check. I think on this one we've used this. It was the which shader did we use? On the scene from Friday. So let's check the Friday scene to check the compute we use, so we could copy paste some of the values. So Friday was this one, and for the second one it was the 27.2. okay, which is correct. I've duplicated, so that's why. So go back here, 27.2. Here we are, 27.2. No, it's not the 27.2, or is it? This is strange. This one only has a curl. Oh yeah, I found 26. It was scene 26. It was this scene, but we've used a compute from another scene. So in 26 we've used the 24.2. okay, that's it. So go back to our own scene. Okay, so yeah, we tried to use an offsetter using a random pose, and we use an offsetter for our pose here. So let's use that here. Okay, so basically for the offsetter, we've took the index, we've used the oppose w, which is a random value, and then we use property.id.data.y, which I don't think is something interesting here, because we might be adding some elements. So let's say we only want this one. Then we use this, okay, and then we use the index plus this multiply, and this one, this two was offsetter. Okay, so if I say something like that, we would have something really messed up. Now it's more like a cube because the offsetter is too big. So if you wait until everything is unlocked. Salut Savinien, c'est en effet un très grand coup de vent. So yeah. So now if we want to say something like 005, I think 005 might be too big, but let's check. As you could see, it's a little bit big, but the thing is, let me just think about it. As we are using particles, no, we will have some random, so no, let's keep using some random value. I was checking if there is some kind of an area we could use. So 0.1 might be not big enough. For the sake and the visibility of our little element here, let's disable everything except the albedo to be sure that we could see everything. Too much glow will be too much. Okay. So as you could see now, there are two on the same spot, so it's not really interesting. So yeah. So 0.1 is not interesting. This is kind of more, a little bit more interesting now. I think I will go with the 0.5, which we've got already at first. Okay, now that's kind of interesting. Let's try to deform everything. So what we want is, let me think about it. We don't want to change the scale right now. So let's disable the scale for the moment. So now it's more interesting as we wanted. So maybe we can increase a little bit the elements. Let's try that. Okay. So let's focus on the same thing. So first we need to check to change this. I don't need all of this curl for the moment. I will come back to it later, but for the moment, no curl, no animation for that. Okay, so sequence is not needed. And basically, all of that is not needed right now. And I think I don't want to rewrite the size. So let's say that we want a full 3 size, which is basically of course I know what is it. Do we need the model's description? Yes, it is. Okay. Okay, it's more something like that. Okay. And this is it. So now we have the way the size is growing. Outquad no matching over here. These things here. So now we could see something growing. So, and you know what? In order to be sure to see everything growth, we would put some basic time. So let's say 2 seconds, and it will be the same for everyone. Okay, we could see the pop, pop, pop. So it's okay. We could also, I think, the particle will grow, etc. So I think we could change that. 0, 1 minus, yes, let's say -1 multiplied by the smooth step of 0.9 1 long time. So I could have a scale in, scale down on that. So we have the begin and the end of the animation now. Yeah, we've seen the glitch. So that is okay. It's really quick, but it is okay. So I think I will not rewrite this little guy here, this little fellow. So what we want, of course, is basically, I think I would need to put, yeah, I would need to put that. Okay. Trying to think about the way we will check after that, but it might be interesting to change a little bit the randomness to be sure to be on the mesh, something like that. So if I disabling the randomness here on the rotation, for example, okay, so no randomness here, and if I'm disabling also the update of the rotation, I might be able in the offsetter to simply say that R&D pose. I'm not sure about that, but let's try. Because of the matrix, I'm not sure, but if we don't offset the y-axis, what's happening? Yeah, nothing interesting. Of course, I was a little bit not worried, but I was thinking about that. Maybe because of the matrix rotation, I would be able to only have a random value around the vertex, but no, it's clearly on the sphere. So yeah, something that we need, of course, is saving the normal. So we have it here, we have the norm listed. So I need to save the normal in order to be able to scale, to march along this vector on the computer. So let's say normal is basically equal to the norm list dot random index. So hey, yay, this is it. And in fact, let's put the normal into our vel. So let's say x, y, and z. Okay. Okay. So now I could be able to use this. So I have a ramp based on the norm map, so that is okay. So I could simply say, for example, we have this, and this is not the vel. I will rename this as the norm. Okay. So let's check vel. Okay. We need to change that if you want to. So yeah, if I simply said now, so 3 norm offset, I'll call way. This is the mean scale plus the norm. So multiply by the norm, sorry. Oops, okay, so this is basically the mean scale plus the RAM size multiplied by the max scale minus the mean scale multiplied by the norm in order to have a normalized vector between the mean scale and the max scale. But because the mean and max scale is really not, I think I would need something like a mean offset and a max offset, but we will try that. And I could say this plus this. Okay, so let me try using a mean offset and a max offset. So mean offset and mean offset and max offset. Okay, no, mean max offset, mean offset. Okay, so now we would say something like uniform float mean offset, uniform float max offset. I would need to put this new value here. Let's say public float mean offset, public float max offset. And here let's say compute dot set float mean offset would be mean offset. Oh, and I made a mistake here. Compute dot set float max offset. This is the max offset. I need to correct this little guy here with that. So everything is passed through. So let's hope we haven't made any mistake. Seems okay. So let's say mean offset of 0, for example, and a max offset of 0.5. I think it would be too big. As we've noticed when we've used a little random, it was too big. So let's say 0.1. Yes, this is it. So we have some kind of a particle based on this. So of course we would need to add our little random offsetter in order to be sure to enjoy all our little particle here. But the base system is clearly working. So let's say 0, 0, 1, and let's say 25 to check. Might be a little bit too much. Oh my. I'm thinking about rotating a little bit the normal, you know. Instead of using a little random offsetter, which is basically scattering around, offsetting a little bit the vector on a sphere. So basically we have the vector and we simply adding a vector around it. I was thinking more about having the vertex. We have the normal, and maybe it might be interesting to shift a little bit this vector around. Let's say it might be so maybe if we have this vector, let's say a random value on the z. So if this is the y, so maybe on the x and on the z, so maybe this and this. So I would scatter here, or this, and I will scatter here. So it would be more interesting to shoot a ray into a random rotated vector. Whoa. What's happening here? I think that might be our random value. Yeah. Okay, 0, 1 is definitely the most interesting thing.
Voici quelques résultats de recherche.
Okay. So let's try to change that. Let's try to change that, but by simply trying something like that. First of all, it's kind of the same here, but we need two things. So I'm thinking about maybe if I'm yeah, maybe it might be working. So our random offsetter is here, so this is our fruit value. And we don't want to rotate on the y-axis, so I think this and this might be enough. So let's take this little guy here and say 0. So yeah, I would need to scale this, of course. So let's say random pose, and let's scale this little bit to 0, 0, 1. And now I would need to define a new float 3 new norm, which would be equal to the multiplication of our matrix. So it's a 3 by 3 because I'm multiplying a vector 3, and it's taking the angle. So let's put a random angle, float r in the angle, something like you know what, let's choose simply the opposite w, which is already a random value, multiply by 2 minus 1 in order to get a value between 0 and 1, multiply by 0, 1, multiply by b. So I'm scaling between minus 1, 1, and scaling again between minus 0, 1 and 0, 1, and multiply by b. So I could have a random angle and my axis, which is basically this random pose vector, and I could use that here, and I might end up with an error here, so which is it? Oh, it seems to be working. Yeah, it's working. A little bit too much, but it's working. If I'm going this, I think P would be too much. 0.5 P might be enough, because I'm able to going on the other way. So let's say something like that. Okay, seems good to me. And now we have more elements now. Okay. As you could see, we are now have more elements. Yeah, something like that. So now we could try to add the curl noise. So the idea was to move around the position. So in order to move around, it might be something like that. Okay, let's use this curl. Let's say this is a float 3 T-pose for target position. Okay, then T-pose will be simply equal, position, sorry, will be simply equal to something like that, to the curl plus the T-pose. Let's try that. Whoa, ho, ho! modify the curl scale. So yeah, the curl scale now is really small. Clearly not that interesting. Okay, so I know what's happening here. So basically I need to redefine the position. So this would only happen when we're redefining this, something like that. Okay, and now we could reactivate the random time. In fact, I think I would need to use the sequencer. Doesn't think so, but I think I would need to use it. So, as the other thing. Thing like if a loop modulo of 2 equals 0, else Ça marche. À tout de suite. Salut. Ok. The behavior is kind of strange. I think I would need to focus on it. Some elements are moving in diagonal. Might come from the rotation using the norm. I think I know the problem of using the pose for the curl, but I think it might be more interesting to fix the old position into it. Let's try that. Let's say we will use the norm, for example. So let's try to change the original pose, because I think we didn't use the oppose. So let's say property oppose is equal to the position, so dot xyz dot xyz. 305. Yeah, now it's more interesting. Okay. Okay, that was more the idea I had at first. Let's say that the speed of the code is a little bit more, let's say 4, and let's use this to check. Okay, so now I could say something like 0.005 plus oppose a W multiplied by 0.005 to have a different curl noise. And if we want, we can also try to offset this little guy here with something like step of 0.5 between oppose the W. Basically, I'm clearly trying to offset everything to bring more randomness into it. The OSC mat. So we could change this part here. Did we use the model description here? Yeah, of course we use the model description here. So let's say float1, float3, 1, 1, 1, because we have the same model description. And we send this all scale. Oh, and I don't need that part also. Okay. Let's increase a little bit the number of elements. Oh, maximum limit allow. Yeah, I would need to increase some of the elements. and we could scale up a little bit. This. As you could see now, it's clearly more interesting. So times to bring some color into it. So let's go back to that word. Let's get rid of the old element here. 0, 0, 0. Okay. So something that might be interesting might be to work with the plastic, because it was kind of an interesting element. So the color is clearly not interesting for the plastic, but the ruggedness is great. Let's use the same for that. Let's use this. Or the same value as the quartz, I think might be better. Ruggedness. This and the quartz. Yeah, it's better. And now we can try to play on on this. We could reactivate everything. Whoopsie doopsie. Okay. And we would need to put various things, I think, into it. And the noise call might be a good way to do that. Let's put the noise call here. So we have a ramp, so let's say fix for ramp is basically equal to the text to the albedo ramp to the float 2, and again we would use in.data.y and in.oppose.w to go into the two little elements, the two row and the column of the identify noise call. Where did I put that? Of course I've put this here. Oh, it's not already here, so I will need to compute it every time because it's the color system. So okay. And of course now the ramp is okay, but I haven't applied it, so let's use it. So let's use clearly the ramp multiplied by that. Let's blur the environment totally. I clearly need a color which is basically the plaster. I think the ruggedness of the plaster might be better. Yeah, now it's interesting. And maybe for this one we could add dark value into it. So let's take our model here. I'm not quite sure about that. I think I would try something like that. Let's say 0.5, 0.25. Okay. Might be interesting to play with two things. Okay. So first of all, we would keep that, but with 30 elements, and we could copy that and paste it so as new, but with something bigger. Oh, I forgot to duplicate the material. I need to retake this in order to say the material might be an instance one. Okay, and let's generate a new noise, because this noise is clearly not that interesting. So I will create a noise noise shade. This would be the name, and it would be based on this plus this, and I will bind that instead here. Where is it? Okay, it's colorful. Let's try also here, try to set the norm time. I want to check something. For example, multiplying this by the norm time, which is stock in this .data.w. Let's check. in order to bring some darkness into it. Clearly it's not interesting bringing some darkness into it. Maybe only playing with the ramp is better. This is clearly better. I think I would also try to little bit change the scale of that part, to change the scale really quickly. I think this is the first thing we need to so if it's more something like that. In fact, if we're on the first part, then we will have the scale, and if we are on the second part, then we have the scale down. It depends on the loop we are. Strange. Oh, I say multiply, but it's minus. Okay, we have it. We have our little guy. I think it's interesting, not perfect, but interesting enough. So this one is okay, this one is okay. We might be also increase a little bit this one here. Maybe it's too much here. Let's keep only that. And yeah, I think it's okay. This is a little bit the idea I had in mind and what I wanted to achieve. So I'm quite satisfied with this colorful experiment. I've missed one with full of color. So I hope you like it. And I'll show you again